Okay, it's time for the latest installment of the series.
Say that again?
I used to be so lost with sigma notation, but now I see it as easy marks, and you will too by the end of this video. I don't think I've got enough subs to have the chapters thing, so subscribe and you shall get that upgrade in due time. So with series we have a sigma to show that it's a sum, a start number and an end number, and a function of r. We substitute the start number into the function, and then we get some output. Then we sub in the next number, and we get another output, which we add to the last one. Then we keep going until we sub in the number on top of the sigma, add them all up, and there you have it. But subbing in each number and then adding them all up can sometimes take forever, literally in some cases, and we're hustlers out here, got places to be, so we use shortcuts. Okay, with this there's no r to substitute in, so each term is just 1. You could think of it as 0r plus 1. So we have n lots of 1, or in other words, n times 1, so the sum is n. You can replace 1 with any constant and the same logic applies. It's just the constant times the top number. So the sum from 1 to 4 of 2 is just 2 times 4, so 8. Or the sum from 1 to 100 of 3, that's just 3 times 100, so 300. Okay, this sum represents the sum of the first n natural numbers. Now you should know this equals half n plus 1, and you should know the proof. The proof's pretty simple. You just write out the sum, write it in reverse, add the two equations together, and we see that each term is n plus 1. So we have n lots of n plus 1, which is 2s, so then to get s we just divide by 2, and that's our identity. So the sum from 1 to 100 is just going to be half times 100 times 101. So the answer is 5050. Okay, but let's say we want to do that sum, but instead of starting at 1, you start at 50. Well, it's the same thing, except we take away the sum from 1 to 49. So the sum from 50 to 100 equals the sum from 1 to 100 minus the sum from 1 to 49. Now we know how to calculate these, so subtract them and then we get our answer. So the general equation is this. You do the normal sum, then you subtract from 1 before the bottom number. Okay, now chances are you're not going to get r as your function. So what do we do when we have something like this? Well, we can use the linearity of sums. Linearity just means we can take out a factor and we can split up additive terms. There's a bunch of other things that are linear, but let's use these facts to calculate this. First, we can split up the terms. Now we can take a factor of 2 out of here and just evaluate this. It's just 4 times 10 in it. This bit we know how to compute and then just simplify. Now let's do an example where we don't start at 1 and we have to use linearity. First we split it up into the sum to 30 minus the sum to 9. Then we use linearity to split each of these up. I think putting the brackets here makes it harder to mess up your negatives. Use the identities and then put all this in your calculator and boom. Now if you've got a CG50 or even the Brokey A-level calculator, then you can check if you got it right by using the sigma notation thing. Okay, sweet, let's move on to the sums of squares and cubes. If you've understood everything so far, this will be easy. It's just 2 more identities to memorize, but everything else is the same. The way I remembered these is by comparing them to the one we already know. So the sum of squares is the same, except instead of a half, we've got a sixth. And we've also got a 2n plus 1 on the end now. And the sum of cubes is just this one squared. You see? Another thing to help you remember these is that the function of n will have a higher power than the function of r by 1. So what I mean by that is, here we have r to the 1, and we've got an n times n here, so we're going to have something with an n squared here. Forget the coefficients, we're just looking at what the highest power is going to be. With r squared, we have 3 n's being multiplied, so we have n cubed. And with r cubed, we have n squared times an n squared, so we're going to get an n to the 4. So this should prevent you from mixing any of these up. Like if in an exam you can't remember if r squared is this or this, you know to pick the one with the n to the 3. But like I said, these are things you're just going to have to memorize. So let's just do this question to test what we've learned. Use linearity to split this up. You've got to get to the point where this step is just very easy for you to do. Now we just use our identities and expand these brackets. Okay, now what we don't want to do here is expand everything out, because it's just going to take ages to multiply and simplify it all. So when we get something like this, we want to look at what we can factor out of all these terms. Well, each term has an n, and these 3 have a half, so let's factor that out as well while we're at it, just to make the process nicer. So we're going to factor out half n from each of these. And watch out for that last term as well. We're taking out the n, and we also got to double it because we're taking out a half. Now we just simplify the bit inside the brackets. This is just binomial, but we times by n, so we're just going to add 1 to each power. 2n squared plus n plus 2n, so 3n plus 1. Add the like terms, so n cubed, 2n2, so 4n squared, 1, 3, 1, so 5n, 1, 1 and 8, so plus 10 and done. Okay, let's wrap up by running through a few problem solving questions. If you actually want to get good at this, pause the video and try these questions first by yourself. It doesn't matter if you get it right or wrong. If you've had to go on your own, then following the rest of this will be 500 times more effective. But do come back because I do need the watch time. Alright, so for this one, let's split it up into the sum to 2n minus the sum to n. But now we have a sum from 1 to 2n of r squared, but our identity is just 1n. So what do? Well, in cases like these, we can take whatever's on top and treat that as our n. And then we just sub that into our identity. So wherever we have n, we just write 2n. And then for this one, we just use the normal version. Multiply this out. You have to get good at factorizing with these questions. Okay, now we want to be left with one term as our answer. And the question literally tells us what to factor out, right? It's just this bit. But if we weren't told that, we could still see that we have an n and a 2n plus 1 in common. Then we want to factor out the fraction so that we get nice whole numbers to work with. So let's factor out a sixth n 2n plus 1. And this is 8n minus n. So 7n, and this is 2 minus 1, so plus 1. Then we get a is 7 and b is 1. Part b is very easy. We can clearly see in this case n is 15, and then we just sub that in and put it in our calc. Alright, let's rapid fire part A here because it's pretty similar to what we've done before. Expand this bracket, now we can use linearity, use our identities, factor out half n plus 1 and simplify this bracket, and boom, easy 4 marks. Alright, now for part B, we're going to turn this equation into an equation in n. So first let's turn the right hand side into a polynomial in n. You know the drill by now, let's factor out half n plus 1. And now we can cancel these two out. Bringing this over makes it a 2, then times everything by this 3 and then expand out this bracket. Bring everything to one side and then let's peep the discriminant. We end up with 39937, which is positive, so wait, we do have solutions. However, 39937 is not a square number, because we get some decimal when we square root it, and n has to be a positive integer, so therefore we have no solutions. Alright, this last one's from 3a because it's a bit different to the other ones. Okay, so we have an n squared and a 4n, and we're trying to get that function of r. Well, we know that this formula has an n squared, and if we expand it we get this, but this is half n squared, so if we make it 2r, then we'll get a 1n squared, which is what we want. But now we're still missing a 3n, right? We want a 4n, and we only have 1. Well, we know the sum from 1 to n of the constant k will give us kn, so if we use k equals 3, then we'll get our 3n. So now we just add these two together and then we get our function of r. Let's just check that this works, and yes it does. Very epic. Alright, congrats on sticking to the end. Double your attention span, you are gonna make it. This time I went through the questions in more detail than I did in my argon diagrams video. The reason I went so quick in my last video was just for that sweet retention. However, I don't know if I want to curate my content for people with brain rot, but let me know in the comments if you prefer it this way or you want more keys jingling. Also tell me what kind of content you want, like if you want normal maths videos, maybe some second year stuff alongside these Core Pure 1 videos. I was thinking of doing chemistry and maybe some physics videos as well, but I don't know if that would make me the one-stop shop guy or it would distract from my niche of being the maths guy. But I am goated at chem and I don't think others can teach it like I can, to be honest. It'd be a waste of potential, but we'll see innit, let me know. Alright, like and subscribe innit, and go do every odd question in chapter 3. I mean, eventually you're going to want to spin back and do every other question that you missed.